Yesterday we were talking about if we have a scatter plot, we're going to use it to make predictions. Everyone got one? We can use it to make predictions. We can use the line itself on the graph to make a prediction. But then we were saying, right, is the prediction reliable? And what were the things that we can consider whether it's reliable? Well, there's a few things. Give me some things we have to consider. Gordon.
The strength of the scatter plot.
Strength of the scatter plot or strength of something else? That's the correct vocabulary.
The strength of the correlation.
Strength of the correlation. Yeah. Who can tell me what it means to have a stronger correlation? Yep.
The points are more linear.
Okay, it could be more linear if it's a linear correlation. Yeah. And
The data will be more accurate. Reliable.
and what do we mean by reliable?
The information will be easier to see trend.
I think you're kind of drifting away from the question I've given you. My specific question was, if I'm looking at a scatter plot, how can I tell if it's a stronger correlation or not? Alison. If the points are nearer the line, yeah? The point I'm getting to there is that I want to say the points are all closer together. Remember we said that. So if the points are nearer the line, that's why I said linear, maybe, maybe not, because it might not be a linear correlation. All right, it could be a curve, but it's about whether the points are closer to that line or not. Your line of best fit, we are just happening to focusing on linear stuff, a linear relationship. So we are looking for the points to be closer to that line. And if they're close to the line, we're going to be able to make more reliable predictions. There's something else about reliability of predictions. What is something else we have to consider? Yeah, what's that got to say? How do we have to take that into consideration? Which one of them is probably fine? Okay? So out of interpolating or extrapolating, which one's probably okay to do as long as we've got decent strength? Interpolation. And what about extrapolation is the problem then? Because extrapolation means we are. Well, I mean, we're going to make predictions anyway, but there's something specific about extrapolating outside the data set. Yeah, so like I said, there's no evidence because we've gone outside of the data set. All of this, by the way, is something I'd expect you to be able to write in an assessment. Okay? Your next assessment is going to be on scatter. Well, no, not your next one, the one after your next one. I put that on management, by the way, today, so the one that you're going to have next Monday. So yeah, all this sort of vocabulary. So I hope you've got it all written down. So we did say interpolating, making prediction from within the data, that I have extrapolation from outside of the data. We've got does the correlation even continue in that way, right? Are the values used even realistic? Can I predict the number of fish when the sea is at 68 degrees Celsius? All right, no, because the sea is not going to be at 68 degrees Celsius. So we then said we can use a line of best fit to make a prediction, but the next stage was to actually have the equation of the line. All right, so we don't need to do the drawing. But what I thought on this graph, the reason why I've given it to you is maybe let's just compare what we get. So on your graph, can't remember, it was something and something. All right, I would like you to predict the y value, right, when basically, what is y when x is 1.8? So using that graph, using a pencil, using a ruler, can you make that prediction? Let's just go through this then. So what is the y value when x is 1.8? So hopefully what you did, we've done this line of best fit before. You've gone up from 1.8, you've read across, got to the line, gone across. And I think it's relatively easy enough to read that one, isn't it? So what do we get? 74. Do you all agree with that one? Okay. Alright, but I did say another way of doing it, so I don't know if that's quite on the line, it might be struggling to read on my screen, but there is another way of making that very same prediction, and I said that was to find the what? We've just found, what's another way of finding y when? The equation, yeah. So remember I said the equation, look, in GeoGebra is really nice because once you've done your line of best fit, it's there. Now, one thing you might remember is that when you first do it, it actually, if I right click on here, it gives me it in different forms, and it will be in a different form, and we can luckily just right click and do it in y equals mx plus b form, and that's nice. All right, we don't have to do any working out, which is, we've got it in this form, but you can put it in the other form if you wish. So can you write that down for me? Y equals 67.51 x minus 47.34. You write it down and I can swap my screen, and then I can write it down and you can tell me what it is. 67.51 x minus 47.34. Okay. You got our in? So the equation of this line is another way. So we can say using the equation of the line. So using technology, the equation was y equals 67.5. 1. See, I already forgot it. 67.51 x
minus
3, 4. Okay. All right. How do we use that equation then? Remember? No, that is the equation of the line of best fit. We're already done with that bit. We're now making our predictions. Basically, we've already worked out we think y should be 74. And now we're going to use the equation to see whether it confirms. Sam? X, we put 1.8 in there, don't we? So we call that substitute x for 1.8. So we're going to do the y value is 67.51 times 1.8 minus 47.34. And if you work that out, everyone get their calculators out and do it. So by substituting x in, right? So replace the x with the value that you want x to represent, and you get a value for y. Do we concur? Yeah? We do concur. That is about the same thing. Slightly more, well, we would say accurate because it's to a higher level of accuracy. Why is it higher level of accuracy? God.
Because it's to the third decimal point rather than to the nearest whole.
Yeah, because when we were reading off the graph, there's no way we can read this one to 1, 2, 3 decimal places. But this one, with the equation we've got from the computer, we can. But is it valid to give it to 3 decimal places? Is that a reasonable thing to do? Should we do it to 3 decimal places? What do you think?
I think it's not reasonable because it's really hard, not impossible, but insanely hard to catch an eighth of a fish.
Well, that depends on what this graph is about, doesn't it? What did we say it was? I mean, this isn't going to be temperature and number of fish. But you're right, if it was fish, 74 would be the right answer, yeah? If this was height and weight, I think it was, wasn't it? The height of a person and their weight. Now, 74 kilos, you might argue that actually 74.2 kilos is easy enough to weigh, yeah? Stand on your scales if you've got electronic ones. We could potentially argue that, well, 74.2 kilograms, if it was, is fine. No.
If a question like this was a test, how would we be able to find the equation of the line without using this?
It's a very good question. At the moment, we are just focusing on technology. But, because it's a very good question, I'm going to ask you. Alright? Let's say, everyone, I have a scatter plot, and I just happen to have done a line of best fit. I've not got the points on there, I've just got the line of best fit. And I wanted to know the equation of that line, mx plus b. How can we do, does anyone remember the process? I mean, you've all done it, I did it with M3s, so that means we all did it. Yeah, Sam, remember? So this value here is b. That replaces that one there, yeah? So the y-axis intercept, whatever that number. Now that there is sometimes there's a case when you can't see that, and there is another process which we can do, but I won't go into too much detail now. That's something we can come back to. But if you remember that, if you can work out where it crosses the axis, that's the b. What about the m? It's the gradient, yeah? And how do you work out the gradient? So basically, without going all mathematical on me, what's the process? What's the y2 minus y1?
Get 2 points on the line.
Yeah, find 2 points on the line. This coordinate would be x1, y1, that's what we're talking about. And this point would be x2, y2. And you, because we are trying to find the rise and the run, do you remember that? So m is the rise divided by the run. So the rise is the y2, where I get to, subtract the where I was, because it gets rid of that bit, so that gives me just that height. So y2 minus y1 divided by the run is this direction, so it's x2 minus x1. So you can use 2 coordinates. So, for instance, in this one here, right, too much grid now, what would I do? Well, if I wanted to know the equation of that line, that I can't see where it crosses, but maybe we could zoom out, but I could maybe pick a point there, and I know its coordinate there, and I know it there, alright? And then I could pick another coordinate, well, I kind of know that one actually, don't I? So if I pick those 2 coordinates, so this would be, what was it, 1.4, what would it be, 2, 4, 6, so 4. It's 1.44, it's a bit accurate. And this one we know is 1.8. So my run is, the difference between 1.44 and 1.8 is 0.36. And my rise, well, that's 50 to 74. So 50 to 74 is 24. So my m would be 24 over 0.36. If you did that for me on your calculator, what do you get? Let's see whether we get the right thing. Be interested. Do it on your calculator. Find out
I
what you get.
forgot my calculator, but I'm gonna put it at a.
what?
6.6.
6.7 rounded. Is that reasonable? Well, look at the equation we actually got. 67.51. We're slightly off because trying to read off, it's probably not quite 1.44. But we're not far away, are we? So that's how you would do it if you didn't have your computer. No, haven't done that. We'll probably have to do more practice. But moving forwards, all right, all I really want you to be able to do is find the equation using technology and then use the equation to make your predictions and then be able to discuss the reliability of that prediction. So can I ask you, using this equation, all right, could you predict, let's say it is height and weight, could you predict y when x is 0.5, please? So using the same equation we've done, predict y when x is 0.5. Right? So, if you're predicting y when x is 0.5, if I've only given you this diagram, it is impossible to use the graph. You don't have it, so we have to use the equation. Have you done it yet? So we do y equals 67.51 multiplied by 0.5 minus 47.34, and we get y equals 5.9%, round it. Yeah, happy with that? 5.85. Okay. So assuming, because that's what I think we're doing, this is someone's height or something's height, and this is the weight. That's what we were looking at, wasn't it, in that problem? Tell me the problem with that as an answer.
Can't have negative.
Can't have negative. Having a negative weight can't exist, right? Physicists amongst you will tell me you can have a negative. What? Say it louder. Mass, good. You can have a negative mass. Is that right?
Yeah.
You can't have a negative weight. Alright? Now, what did we just do with that prediction? We extrapolated. We went beyond the data that we've got. We went below it, in fact. Extrapolation is not always going above, it's going below. And because we extrapolated, I didn't do anything wrong at all, and this is important for your criterion D, we then have to look at it and go, look, my maths, my formula, my equation was correct. I put my number in, I did it correctly, I put it all into my calculator. Everything is correct. That's not the same as making sense. Does that make sense?
Yes.
Yes. All right. This number, this answer does not make sense. All right. And that comes from extrapolation there. In this case, sense like that. Sense like that. Okay. If you're happy with your notes, you are now. So we've just done that question, but what you are going to be doing is all of this. So looking at page 129, practice 3, it says, use technology to draw your scatter diagram. You should be pretty sharp on that now. Find the equation of the line of best fit. Now, what I've not done is I've not given you so that the computer just does the correct one for you. What I still want you to do is go through and decide where you think the line of best fit will be. Now, the issue with that is, if the answer in the back of the book is based on what the computer thinks the line of best fit will be, and yours is slightly different, your answers will be slightly different, yeah? But they should still be reasonable if your line of best fit is reasonable. And then it says, so find the equation line of best fit using technology. It just comes up once you've done the line, right? Comment on the correlation. Use the line of best fit to predict the way. How are you going to use the line of best fit now? When it says use the line of best fit to predict what you're actually going to do. What?
Find the point.
What are you going to do? What are you actually going to do? You're going to use the line of best fit. Use the formula. Thank you. I knew I was being slightly off, but I knew it makes sense. When it says use the line of best fit, we're actually using the formula. Otherwise, what's the point? Find the equation of the line of best fit. We're using the equation. All right. So you are starting page 129. You've got some saying they're pretty repetitive questions, but I think that's fine at this stage. Get GeoGebra open. Let me know if there's any issues with doing that.